Hello everyone, welcome back. Today we are going to try a new model called Depth Pro, which can figure out how far away things are in a photo without needing any extra information about the camera. It's like having a super smart app that can tell the depth of everything in an image with great detail and accuracy. As you can see here, we can see the model detail in Hugging Face, and in the Hugging Face page, you can also go to the code repository to see their GitHub page. There are some additional descriptions and how to get started. Now let's go to check the code. Before we start, I would suggest you if you can activate the GPU runtime option in Colab, please choose it. There are some free tier usage allowance to each user. After using it for some time, it may be blocked, but if you can choose it or if you are a pro user, please choose it because it will let the model provide faster results. Now, to prepare the model to run in Colab, you can check both Hugging Face page and GitHub page. First thing we need to do is to clone the code of the GitHub page to Colab environment. Then we move the directory to the code directory and we install the package, download the model, and confirm the installation. Then we set up the Depth Pro path to make sure our code can easily access the model files when we import from the Depth Pro. Then we check the availability of GPU, and if you want, you can also do this part of the code to do additional check on the number of GPUs available. And here we're importing image for handle the image in later stage, and import this package of Depth Pro. And of course, these are some checks to make sure that the GPU is available. There may be some redundancy in my code, but I would suggest you before you move to some critical points, always check if the device is available. Next, we load the Depth Pro model and a transformation function that will help us prepare our images for depth prediction. We'll move the model to GPU if it's available and set it to evaluation mode since we are only making predictions. Then we can also print out the status of the GPU if we want. Now in the implementation stage, you first need to prepare all the dependencies that's needed. Then we create this function to display original and predicted image side by side. And the next code block is going to process and display each uploaded image. And the most important part is in the middle. We just load image, move to GPU, run inference on GPU, and retrieve the depth map back to CPU for visualization. And eventually, we just run this function to upload, process, and display results. As you can see here, each time when you upload the image, the model is going to process the image and provide you with a predicted depth on the right. I'm choosing some images I find online. So the first one is a forest and mountain picture. And you can see this model can do quite a good job to let you know the depth, which you can interpret as the distance of the object from your standing point. But in some other cases, like this one, this is an image about the field. The part that you see here is not the same distance to your standing point from each point of the view, but the model can only detect some part of it. So I guess there are also some limitations, right? Because you cannot see like every individual object is precisely analyzed. Then we see this mountain view. Mountain view, I can tell you that this mountain is like in the middle of the depth of the picture. Then you can see there are further mountains in the background, and there are some green parts very close to us. Okay, the model does some job to identify some objects close to us, but some other parts are very fuzzy. Then we see this picture of the cathedral. Yeah, it's doing a better job because you can see there are many people identified which are close to us, and we have also a cathedral in the middle, then the sky in the far end. Then we can also see here this one is is inside of the building, and we can see there is a depth, which means that all the viewpoints is leading to one door. You can see here after processing, we can see this is the direction where everybody is going, and you can also see the people here. So it's doing good job. And then this one is about a football stadium, and you can see it identified some of the poles very close to us, and the stadium is like in the middle. It can also identify the edges, but for the lower side, it's not very easily detectable. So the model does not put dark color here. And you see this one is inside of the football pitch. About this picture, we can see the light, and we can see there are some sitting places in the stadium and also the pitch. However, the model cannot predict the depth correctly because you see it's all fuzzy. Then this is another picture. This picture actually is showing the cathedral in a very close distance, but the model just gets a very fuzzy prediction. I mean, it's not like the previous one, like this one. From some distance from the cathedral or inside of the building, we can see quite clear the main object and the main object's distance. But these two, about the inside of the football pitch and the close image, they are not doing so well. Then we take a look at this picture is a street view of New York, and you can see this one. The prediction is quite precise because you see the most close objects like this car and the one person riding the bike are clearly identified, and we can also see the further we go down the street, the distance is going to increase. So in general, this model works fine. And if you are interested in this field or you are interested in playing with model, you can try it using this code. So there are many open source or free models on Hugging Face. I'm going to try them and also share with you in later videos. But before I end this video, one thing I want to mention to you is that usually for all the free model, there is a very clear description to tell you how to use the model, how to try it, and please also pay attention to the license type of each model because some of them don't have the limit of usage, but the others may have. I do encourage you to check the different resources in Hugging Face or in other sources and try these models so you can better understand what the model does and if you can incorporate this model to your workflow or to your product. I wish you like this video. If you like it, please give it a like. If you like my channel, please subscribe. See you next time. Bye bye.